Alright, now this was my original post, which somebody sent me this picture, and I really don't know where it came from. But the tendon strap goes right in there, and it anchors there, and this particular goopy looking stuff is a structural material that is like specific to wrap that particular strap so it can pull back and forth. This would have lifted up and so forth like that. This would have been some sort of rubbery material, which it looks like to me. And that's how they work, because and you'll see, I'll show you, they pull up and out like that in the fleshy material. Alright, and here it is. Here's the fleshy material. That's the tendon mat. You see these straps, how there's a whole batch of them, and they're all over the place. I mean, there's a ton of these. Now, that ball was supposed to anchor this mat so that the mat could pull the strap against the ball. The ball has pulled out of the hole, and that's a painful injury. Now, so that's what it is. I'm not making it up. It's the way it works. Now, if this was the bone that was there, that ball would be right in that bone. And then the strap would pull the bone back and forth to do all these little articulated things that your fingers do. It's very specific, and it's just obvious. You see them. There's no question what that is, and there's no question that the holes are in the bone. There's no question that's an apical tuft, and there's just no question about the things I'm saying, and nobody will look at them. It's been DNA tested, and it's just a fact. It's very spectacular, no question, by any standard. But it is what it is, and it just deserves a look by some people that could claim to be experts, and that they can either debunk this or prove it. That's all I'm asking for. It could be totally wrong, but you'd have to show me that it's wrong and show me some better explanation for the things I'm seeing. That there's not one single hole in this theory. Zero. DNA is proven 3 times, 7 CAT scans. I filled a 200-foot ditch with what was left over from testing. 200 feet of drainage ditch. I needed rock, so why bother ordering rock? So that's the story. See, this is what learning is all about. Lorraine Palmer sent me all this information after I posted about these giant balls, these giant stone balls, which are all over in clusters like this. And everybody's, oh, what are they? What are they? Well, and I couldn't figure it out either, but I had my suspicions. And now all of a sudden, everybody helps, and we figure out what they are. Well, what those are is tendon ball implants, and I believe those are almost exclusively from the fingertip areas. And I will show you one right here that I have in mud fossils. And here it is right here. This is what they do. This is what's called an apical tuft. Now, this apical tuft is what's on the end of a fingertip, and it's loaded with these holes. They are everywhere. You see those holes? You see them? They're just everywhere. And these things come down, and they grab and they pull the tendons, pull your finger around, do this and that. Now, when these deteriorate, they fall out, and that's what you got. There are a ton of balls and holes. Now, you see that ball at the end? I'm going to show you one that's a little bigger than this one, but it's the same ball. Hold on a second. Alright, I'm going to be showing you some incredibly large tendon emplacements, and I'm going to explain to you the process and show you how this process unfolds, because it's not understood, and I get all these, well, how does this happen, how does that happen? Well, I'll tell you exactly how it happens. You start off with a finger that has flesh, it has everything, it has skin, it has a little hair, a little this and that. Now, what is on the skin? The skin is heavily and dense with silicon, and when you get in the mud and in the wet, silicon is very reactive to oxygen. It becomes silicon dioxide, which is sand. And it becomes cellular little quartzite granules, and they erode from the skin. And then underneath you're left with what's called mudstone, mud rock, and clays and so forth. Now, I'm going to show you what an apical tuft is, and then I'm going to show you what the mud fossils are. Now, this is a finger, and there's your tendons coming through and wraps in the muscles and all this. And that at the end there is what's called an apical tuft, and it's loaded with holes. And just like this, you see that? There's holes, a million holes in the end here. And what happens is all this tendon, the longest or whatever they call it, comes down here, and they tag into those little tiny holes, and that is what allows you to make your finger twist and do all these little articulations, is those little straps coming out of these type of things, invest in there with a million little holes. And those are your tendons that grab and drag your fingers around. And they have a little ball on the end, and the little ball on the end is the things that I'm saying are the gigantic stone balls that we find all over the earth, and they come in clusters, and the reason is there's a million of them in one little spot. And I'm going to show you exactly the proof that proves it. I mean, there's no question about it, but I'm going to show you the evolution of how fingers erode. And let's start with one that was complete. Well, I don't have one with skin on it, but they, you know, I mean, that's what I'm saying, it might be possible. But this is, here, let me back this up a little bit. This is a fingertip, and it was CAT scanned, and you can see all the articulations inside, and it's very, very clear. You see, that's how the tendons come in, and they dig right in. It's a sharp, they grab right in like this, and that's what moves your fingers. There's a million of them. So there's holes all over this, and right up in here is what is called an apical tuft. Now, once the skin is gone off of this, the very outside skin, what's left here is what they call areolar tissue. And you can see all these little tiny holes. Areolar means it's filled with holes, and it is. And then this erodes, the areolar tissue, to become this. Now, if you can see, and I think you can, I hope you can see that black mark? Well, maybe we have a hard time seeing it. But you see that black impression and what it looks like? That's this right here. That's the bone that's inside this rock. This is another finger. It came out of the same hand, and I have the palm, and I have some other parts of that other huge finger, and that's where the blood vessels went inside, the vein and the arteries blow out because they're unrestricted. That's the artery side, and this is the vein side. You can see the veins in there, but they don't blow out. See, there's that angle again that I showed you on the other one. See that angle? That's what they have. Now, this is what's called mud rock, which is the flesh. Now, the bone is in here, but bones don't preserve like they do in the dry because they become invaded by minerals. And the reason for that, there's a lot of reasons. Just believe me, they get invaded and they become hydrocarbons and source rock for the fossil fuel industry. That's what happens. And what's left over is the kerogens and the collagens and the some metals and minerals. But it's almost indistinguishable. Anyway, this is that. Now, what happens after this? You have an apical tuft that I told you here. That sits on there. That's the apical tuft. And here's the apical tuft. You see it? You see all the holes in there? It's loaded with holes. The whole thing is packed with holes. Now, here's what I want you to see, and this is the coolest thing. That tip, and I had a bunch of these, that tip, the ball ends up sticking out like that, like a bump. And I thought, why is that? And the strap comes down, and that's the one that really gives you the anchoring, and that one there doesn't rip out like all the other ones. For some reason, I don't know why. But I had tons of this stuff. Let's see all those holes there? They're all over the place. Now, see, some of these here, they're still left in here, the balls, but that's why they see them such a big clusters of them. Anyway, remember that tip out of there, because I'm going to show you one that is in the ground that is a little bigger than this, but it's the same articulation. It comes out like this, and then there's the ball on the very end, and that ball broke. So I'll show you that in a second. But anyway, that's how fingers erode. You get let's start from the beginning again. Let's take the outside, the skin erodes because it's dense with silicon. Under that you have the areolar tissue, which is that holy looking stuff, and that eventually erodes away and you end up with mud rock. And if the mud rock eroded away and it was a tendon underneath, you would end up with limestone. But with bones, it's different because you have a dense bloody complex internal, and the whole thing changes composition. But tendons don't. They're a whole different thing, and they just never go away. And the earth is literally made of them. They end up being porphyritic limestones. you know, they call it volcanic basalts. They're not. They're porphyritic limestone basalts, if that's what you want to call them. But they're from creatures, and they're from the tendinous structures in the creatures. That's what they are. All right. Now this is like the body's Velcro system for tendons. At the end of all these little fiber, they're actually like little cords. And at the end there's a ball on them, and they insert into bone or tendon or tissue or other things so they can anchor the tendon, so the tendon can pull on whatever it has to pull on, the bone or the muscle or whatever it happens to be. That is the way these things invest with these little balls, and I will show you that. That's why you find them in huge quantities in clusters, because they invest a whole bunch of them right in one area, and then the cords run off of that and they go do their job. Alright, do you see that structure there? That's kind of an interesting structure, and you would wonder how that was done. You could see there's layers. It's a total round thing, like a cannonball head or something. Then you start looking around and you see other round things all over the place. Now, what I'm saying is this is the tip of a finger of a giant creature. And I know you're going to say, well, the guy has totally lost his mind. And, you know, I understand that. But I will show you what that tip of that creature looks like. And there it is right there. And it's laying down this way. And that ball is at the end and has eroded away. And that is exactly what I find in the apical tuft of giant human beings. I'm just telling you, because I've had them DNA tested. They're giant human beings. And 3 DNA tests, 7 CAT scans. There's no question what I'm saying is true. Now, all of these holes all over the place are all over here. Now, I have some other specimens to show you, which are very, very, very conclusive. So that's what I'm saying. You make up your own mind. I don't force anybody to believe anything, because it's so spectacular. Your mind is going to explode, and then you're just going to have to pick up the pieces and see if they fit back together. That's all I can tell you. Just so you know, this is the anatomical development of tendon. And there's bone implant tendons, there's flesh implant tendons, and so forth, muscular tendons. Anyway, this is how they grow. It gets up to here where you've got your mineralization, which is extremely mineralized, and as it petrifies, it becomes plagioclase and olivines, and that's the mineralization of the tendon balls, and they also become porphyritic limestone basalts, and they come in stripes and little blocks, and they have these little separations. They break just like little bricks. I'll show you that in a second. Alright, this is bone tendon, but it's very similar. You have a ball, it implants into flesh or the bone in this case. Out of that bone or the flesh extends a cable. And that cable is this. And that cable has these transitions. It says, all right, once you leave, turn into this. And then it says, okay, you get about an inch out of there, or whatever, 1/8 of an inch, turn into this, and start to add some minerals. Because you're going to be going into the fleshy stuff, and we need you to make a transition between here, here, and here. And when you come down and look at this purple, that is this transition, and it is flat as a pancake. And see those little bundles and balls and stuff? I believe those are the balls that we're looking at. Those are the little tiny balls. And these, you see this? Those are the stripes that are in the tendon assemblies, and they go this way too. So that when they do, in ancient times, they just took these and they broke off little pieces and they used them to build things, and they didn't have to cut them most of the time. Plus, these things were so tall, these tendon assemblies, that they built the pyramids down and not up, and I'll show you what I mean by that. But first, look at this, some more from Lorraine. These are these balls close up, and you can see that life is literally layered, and it's really amazing. And when they petrify in certain ways, you can see the colors of these different laminations in such exquisite detail. It's absolutely phenomenal. And that's what happens because of blood fossilization, and some will be in blood. And when they fossilize in blood, the transition metals that are in the blood, which are specific, very, very specific, unique molecules, will find their exact partner to pair with, and then that determines the color. So that's why opals are so spectacular. The exact molecule that was needed is found, and then they bond and they become absolutely stable. Well, it just doesn't get any clearer than this. That is obviously the same type of material and structure that we see in all of these balls. Now look at this carefully. You have to understand anatomy. Now, if you look at that, and then you look at this, you see that, and you see that, you see this, you see that, and as this thing comes up, it's separated from this thing. And as you see this side, it's quite dark, and as you see this side, it's quite light. And it looks like this stuff has run down and congealed here. Well, that's not the case. This is the vein side, which means that it clamps off internally and creates black, dark ferrous oxide, the O2 style, which is a depleted blood. Now, this supplies this organelle, or whatever you want to call it, with fresh blood, and the fresh blood is oxygenated blood, and it turns rusty in these conditions. It is extremely red blood in your body, and you get actually blue blood in your veins. So your arterial blood is red, your venal blood is blue. Now the venal blood clamps off because there's clamps. It won't let it go backwards, contaminate the good blood. Arteries have no such restriction, so they blow out. And I see this all the time, all the time, all the time. It's just over and over and over. And I can watch the blood actually move from here over to here. If you were on the top looking down, you'd see it would be dark over here, and you'd see start getting lighter and lighter and lighter, and it would get to this sort of color on this side, and as it's being used up. And that is the way Mother Nature intended it, and this is the way it works. And I'll show you. Well, anyway, you'll see. All right, I hope you can see this. I never can tell what you can see in the camera, but this is the side where the blood comes down, and that would normally be bright red. And then as it moves across, you see it turns lighter and lighter and lighter, and then it starts, lighter when I mean rustier, away from the red, and then it turns into this brownish stuff, and then it gets black. You see that? It's shiny black. It's completely expended its blood. It's oxygen, and that's what comes back up. So you could actually watch, and if you look close, you can see all the little tiny blood vessels in there, and that's just what happens. It's just it's a piece of meat. I can't help it. It's what it is. Okay, by the way, I got to do this because I keep getting asked about hearts, and this is a heart. And you see these little dots here, these little black dots. I don't know if you can see those or not, but those little black dots here, hold on. Those little black dots are the heartstrings, and you will always have this angle like this, and one of them will be at least twice as big as the other one. They're the left and right ventricle, and one of them does a lot of work and the other one doesn't. And anyway, they wrap all around the heart. Now this is one that, and then you're going to see these kind of things. And wait a minute, there's another one. You see like that? That's where they invested in there. And there's fascia over this whole thing, like a rubber bag. And that wrapped around the aorta or whatever aorta it was. Maybe the B aorta, I have no idea. Anyway, it wrapped around here, and then when they get ripped out of here, however it breaks off, it sort of clamps up. Anyway, if you look at these things close, you'll see all this stuff. See, that's the articulation you're going to look for. And it's very, very apparent. You'll look for these dots. And you look on Ayers rock, it has the identical same things. And they pull inside in a different type of rock, exactly like Ayers is. They pull in because they're the heartstrings. And they literally look just like this, and they pull right in. All right, here's another one on the stand. That is the tendon fibrils. These are the literal tendon fibrils. You see them? You see those stripes? That's going up, that would attach to that ball. That ball would have been implanted in some flesh, I believe, in muscle area, and this would pull the other stuff that was on the other end of this, your muscles and so forth, against this area, so you have some traction. That's just the way things work. Alright, this is the same sort of thing. This is one of those balls, but I cut it. Now this is in a whole different situation. This is called olivine and plagioclase, and that's what all tendons are. They're olivine, plagioclase. Some of them end up becoming feldspar. And anyway, that ball goes to that strap, and it ran down here. Oh, and here's the rest. There's another couple there was more attachments to this. See this strap here? That strap sat on top of here. And this would have slid back and forth on another one of those balls. They're completely separate. And in between them they have this slurpy stuff. It's called leucine-rich proteins, I believe. I could be wrong, but you put water on it, it'll hydrate. So some bloody stuff. Now, and I have that. You see that one there? It has no deterioration at all. Other ones end up being, see, at the end here, this is where those tendon fibrils would go in there, but that's the abrupt transition. Breaks right off. See it? Just like a plateau. Breaks right off. That's what happens. Now, inside of here, you're going to see, I don't know if you can see this or not, again, but I think you can. You're going to see that is, something has etched out that stuff. Those little holes in there. They weren't there by themselves. And they didn't get in there because of somebody cooking this or anything. This was in a, I believe this was in a volcanic area. That's where we found it. Anyway, this is what happens. And these are finger emplacements. They actually come down, and these go right into the side of your finger, and they make your finger pull back and forth like this. Now, I have a huge finger over here that we did an autopsy on, and that's what it is. And they implant right in there, and these came right out of those implants. So it's just